a circular function. It's not one of the units that we have, but this is something I want to address just because we're going to have a lot of problems, especially when it lands on the unit circle. So specifically the ones that land on the x-axis and the y-axis of the unit circle. So let me address a couple of things. One of the things I want to address is this right here. So using the unit circle, we're going to say then this is my 0 degrees, right? Or radian of 0. Then I have this pi over 2, which is the same thing as 90 degrees. We have a pi, which is 180 degrees. Then we have 3 pi over 2, which is 270 degrees. And then I have is 2 pi, which is then 360. Okay? So the first thing I want to address is that the cosine owns the x-axis. It means that if it lands anywhere on the x-axis, it's going to become 1 or negative 1. Now this right here, normally on the x-axis, this is positive 1 right there because this is on the positive x-axis. And then this right here will be negative 1 just because this is a negative on the x-axis, right? So, for example, let's take cosine of 0. So cosine of 0 will be 1 because it lands on the x-axis and we said the cosine owns it, right? So then cosine of pi over 2 at 90 is equal to 0 because cosine does not own the y-axis. Cosine of pi, or at 180, is negative 1. Cosine of 3 pi over 2, or 270, is equal to 0. And then cosine of 360, or 2 pi, is equal to 1 again. Okay? Now let's address another one, which is the sine. So sine owns the y-axis, so it's similar to the cosine. If it lands on the y-axis, it's either going to be positive 1, because again, this is the positive on the y-axis right there, or negative 1, because this is on the negative y-axis right there. So if I say sine of 0, it's going to become 0, just because again, sine does not own the x-axis. Sine of pi over 2, or at 90, right, is 1. Sine of 180, or at pi, is equal to 0, and then sine of 3 pi over 2, or 270, is equal to negative 1, and then sine of 2 pi is equal to 0 again, because again, sine owns the y-axis right there. Okay? So one more is the tangent. So tangent can only be 0 or undefined. It cannot be 1 or negative 1. So here's my little, corny saying that I have for tangent. So when you're standing up, right, and let's say you're involved in sports or band or swimming or whatever, and let's say one day you go out with a t-shirt on with a sleeve, right, and you get tan. The next day you go out, it's a nice hot day again, but you go out with a tank top. You're going to get different layers of tan, right? So we're going to call that an undefined tan because it's not really defined. You didn't get a perfect tan. That's an undefined tan. So for tangent on the y-axis, right, anything on the y-axis right here, this is going to be undefined. Now, to get a nice perfect tan, if you notice on the beach, everyone is always laying down right there, right, to get a nice perfect tan. So you can see right there, that perfect tan, that 0 right there. So anything tangent on the x-axis is going to be a perfect tan, which is a 0 right there. So tangent on this right here on the x-axis is going to become 0. Okay, so let's try this. Tangent of 0, then it's going to become 0, because that's a nice tan right there, right? Tangent of pi over 2 is going to be undefined, because remember, that's the standing up part of it. Tangent of pi is 0 again, because again, you're laying down straight, laying down on the x-axis right there, so you get a nice perfect tan. Tangent of 3 pi over 2 is going to be 0, undefined again, and then tangent of 2 pi is going to become 0. Okay? So those are 3 things. If you just work on those, that's going to help you, especially when it lands on these right here. Now, obviously, the 45 degrees or pi over 4, and the 30 degrees and 60 degrees, you're going to have to create special triangles for those. So you can do special triangles and figure out that rest of that. Okay? Another thing I want to address is when using this unit circle again for the derivatives. So when we do derivatives and it lands on any of these x-axis or y-axis, derivatives, it goes down, rotation-wise. So we say that we're down with our derivatives. Okay, so for example, if we take the derivative of sine right there, it's going to become cosine. Derivative of cosine is negative sine. Derivative of negative sine is negative cosine. Derivative of negative cosine is positive sine right there. Okay? So that's where the derivative is. If you can remember this rotation right there, that's going to help us, because when you do, a lot of times the UV, you're going to have something like negative cosine, right? If you take the derivative of negative cosine, you're going to remember it's going to be positive sine. So you don't have to worry about is it positive or is it negative, because you just have to remember is the rotation for this. Okay? Now later on, when we do the antiderivatives, right? This is going the opposite direction, so we're going to go up on the integration or the antiderivatives. So when we say, for example, the antiderivative of sine is going to become negative cosine. The antiderivative of negative cosine is negative sine. The antiderivative of negative sine is positive cosine. And the antiderivative cosine is then positive sine. Okay? So that's going to be the rotation for the antiderivatives. Now those three things, if you can get those down, then you don't have to have it memorized or anything like that. You just remember the chart and the rotation. Alright? So good luck with the rest of them then.